So in looking at how to calculate a heating curve, you want to know what area and what region you're working in. So the best thing to do is to sketch your heating curve. So in this example, we have how much energy is required of 100 grams of water at 20 degrees Celsius to steam at 300 degrees Celsius. So for the first thing, I want to see where I'm at. So a 20 degrees Celsius would be about this area here, and 300 degrees would be about here. So when I look at this, I realize that I've got three regions I'm looking at. The first one being this area, the second region being this flat part, and then lastly the third area being this last incline. So if you watch the last tutorial on understanding heating curve, you'll understand how we know what formula to use and why. So let's go ahead and get started with the calculations. So for region 1, I see that I have a change in temperature, so we're going to use Q equals MC delta T because there is a delta T. The mass in this problem is 100 grams, so 100 times. And when we look at this, I'm in the solid region, which tells me that this is the water, and up here is the gas, which would be the steam in this problem. So for the C value for area 1, I'm going to use the specific heat capacity of water, liquid water, which is 4.184. Now the delta T, I'm only looking from 100 all the way to this temperature, which was 20. So I would do 100 minus 20, which is a delta T value of 80. So when we calculate that, we get 33,472 joules. So area 2, I see that there's not a change in temperature. It's flat, it's constant. And remember, this is considered vaporization in this section. The first section is fusion. I remember that because F comes first in the alphabet, so fusion comes first in the graph. So for area 2, this is going to be Q equals mass times the heat of vaporization. So in solving this, the mass was 100. Heat of vaporization is 2,260 for a Q value of 226,000 joules. And then lastly, area 3 is a change in temperature, so we're going to go back to Q equals MC delta T. Mass is 100. Now the C value here, because we're dealing with steam, I'm going to use the heat capacity for steam, which is 2.0. The delta T in this case is, if I look at this area here, this was at 300 and I'm going all the way to 100. So I'm going to be looking at 300 minus 100, which is a change in temperature of 200, which gives us an overall value of 40,000 joules. The final step is to tally up every Q value. So I'm going to be adding Q1, which would be here, Q2, and Q3. Add them all up for a total value of 299,472 joules. And that is how you calculate using heating curve.